Welcome back to this lecture on proofs in predicate logic. In this third and last segment, we're going to consider a second example of an argument, and we'll try to use the new rules, inference rules for quantified statement to prove the validity of this argument. The first sentence S1 in this argument states that all students enrolled in Math 212 have completed CS 221. The second sentence S2 in the argument states that some students are enrolled in Math 212. And the third and last sentence in the argument states that Abigail has completed Computer Science 221. So this is an argument with three sentences, S3 being the conclusion and S1 and S2 being the premises. The first step in studying this argument is to convert it to logic. In other words, to exhibit its structure or the form of the argument in logic. S1 is one of those common statements that says all students have done so and so. So it's going to be a for all statement. We're going to use the predicate m of x to denote the fact that x is enrolled in Math 212, and we're going to use the predicate c of x to denote the fact that x has completed CS 221, where the domain for x is, say, for example, the set of all students at UW-Oshkosh. So the translation of S1 in logic becomes for all x, if x is enrolled in Math 212, m of x, then x has completed CS 221, or c of x. Now S2 is a little bit easier. It just states that there is at least one or more students that are enrolled in Math 212. In other words, there exists x such that m of x. And S3 is even simpler since it doesn't involve a quantifier. It states that a specific object in the universe named Abigail has completed CS 221. In other words, C of Abigail is true. So now that we have the form of the argument or the logical structure of the argument, we can ask ourselves whether this argument is indeed valid. By which we mean, is it true that the conclusion S3 is a logical consequence of the two premises S1 and S2? To answer this question, of course, we're going to try and build a proof, a formal proof, where we're only allowed to assume or start with the premises here, and we must end up proving that the conclusion must also be true. So the first step in our proof has to be one of our premises. Let's pick the first premise here as our first true proposition of the proof. Now, what can we infer from this premise? Well, this premise is a universal statement. Therefore, we can instantiate it by replacing x with any specific object in the universe. And here, of course, we're interested in Abigail. So we're going to instantiate this proposition using Abigail for x. In other words, our second statement or true proposition in our proof will be, if Abigail is enrolled in Math 212, then Abigail has completed CS 221. Don't forget to justify your inferences. The justification for the second proposition is the application of the rule universal instantiation applied to proposition number 1, namely this one in the proof. Okay, so this is pretty much all we can do with the first premise. So why don't we introduce the second premise as the third proposition in the proof, namely there exists x, m of x, and we're trying to prove that C of Abigail is true. And notice C of Abigail is the conclusion of this conditional here. So if we could establish the hypothesis of the conditional, namely m of Abigail, then we could use the modus ponens to infer the conclusion of the argument. So really we're interested in getting this proposition, M of Abigail. Well, here's the good news. Proposition 3, which is true as a premise, says there exists x such that m of x. So we're going to proceed to instantiate this existentially quantified proposition by replacing x with a specific element of the universe. And we know that that specific element must exist, since it says right here, there exists at least one x such that m of x. So of course we're going to pick Abigail to replace the variable x, and therefore we can infer m of Abigail by application of the rule existential is instantiation applied to proposition 3. And now we're home free. As I mentioned before, we can apply modus ponens to propositions 2 and 4 to infer that C of Abigail is true. Now that we're done writing the proof, before you consider it done, I strongly encourage you to always double check your work. It's very easy to make a mistake, and it would be a shame to not get full credit for such exercises. So in particular, I encourage you to double check that you didn't make a mistake when you converted from English to logic. And as far as I can tell, that looks just fine. And then make sure you didn't make a mistake when writing the proof. So common mistakes include copying a premise wrong by having a typo in there, or forgetting to justify every step in the proof. Looks good in this proof. Another error, of course, would be to misapply one of the new rules that we just learned about in this lecture. For example, the universal instantiation and the existential instantiation. So, are you convinced that we didn't make a mistake when we applied those? The only way to check is to go back to your notes and to check the definition of these inference rules and make sure that we applied them correctly. So please pause the video and double check your proof in detail. So hopefully everybody noticed that there is something wrong in this proof. In fact, you may even have noticed that there is something wrong in the argument altogether. So let's go back to this argument and consider it again. The strange thing about this argument is that the conclusion is about a specific element in the universe called Abigail, but this person, this student, does not appear anywhere else in the argument. So that's a little strange, unless of course we had a statement that said, for example, everybody in the universe, that means every student has completed CS 221. Then it wouldn't be surprising that we can infer something about any specific student like Abigail. But at least we don't have such a general statement about everybody having completed 221. So maybe when you heard that argument for the first time, I hope that you had a gut feeling that something was wrong. Another way to convince yourself of that is, notice that you could have replaced this name by any other student in the universe. So by using the same argument, if it's valid, I could have actually inferred the fact that Ben has completed CS 221, or Mary has completed CS 221, or for that matter, any other student at UWO. That doesn't sound right. In fact, this argument is not valid. So I hope you realize that. The translation to logic was actually correct. The problem was in the proof. So let's go through the proof again slowly and realize where we made a mistake. The first proposition in the proof is a premise. We copied it correctly, so there's no mistake there. The second proposition is a correct application of the rule of universal instantiation. Remember, that rule says if you have a for all x in front of a proposition, you are completely entitled to pick any arbitrary element of the universe and plug it in for x. So there's nothing wrong here. I could have used Abigail or Ben or Mary here. Of course, I put in Abigail because that's what I was trying to prove something about. So how about the next line? Well, that's not an error either because the premise is correctly copied from the argument. So let's consider the next line. And this is the last time where we used one of these new inference rules. So we should be careful about this one. And of course, it turns out this is the place where we made a big mistake. Notice what we did is we instantiated this proposition and we placed x by the constant or the individual in the universe called Abigail. But that is a mistake if you, as I ask you to do, review the definition of this rule. It tells you explicitly that when you pick a specific element of the universe, you are not allowed to pick a name that has already appeared in the proof. And of course, Abigail already appeared in the proof over here, step 2. In other words, this is where the error lies in this proof. You're not allowed to instantiate proposition number 3 with Abigail. In other words, we made a mistake when applying the existential instantiation rule. So let me emphasize this point again, this idea of introducing the names of specific individuals in the universe. Why was it okay to introduce the name of the individual Abigail here? That's because if we know that a particular property is true for every single element of the universe, you are free to pick any one of them. The difference here is all we know is that there exists at least one element of the universe for which M is true. But since we don't know who that element is, just that there is one, you are not allowed to determine arbitrarily that that element is the same one that you already used in the proof. In fact, it could be the same, it could be different. So in general, you just pick a different name just to be safe, to make sure your proof is valid. And that is the reason why here you are not allowed to replace X with Abigail, because Abigail was already used in the proof, in an earlier step of the proof. So in conclusion, not only this proof is wrong, but the argument is not valid at all. So this is really more of a counterexample than an example. And this concludes our lecture on proofs in predicate logic. Make sure to spend time understanding and remembering those 4 rules of inference for predicate logic, as they will be very useful to us in the rest of the course.